Hello, hi, good morning. This is Basavaraj Rachiti again with our favorite subject, energy engineering for PE, mechanical engineering students, and also third year mechanical engineering students, also useful for diploma students. So we were in the last phase of second unit with environmental impacts, part 2 today, lecture number 8 of that. And before again going to start with the topic, new topic, let us have some brush up of the last class which we have discussed. So we saw that environmental impact, how the impact of this thermal power plant on the surrounding takes place. The first is air pollution, second is soil quality deteriorates, land erosion, land erosions, water extraction is more, soot problems, acid rain, and air pollution. So these are all the outcomings of the thermal power plants or some of the other power plants also. So this causes this having very serious impact on environment, and we have to study it and we have to control these factors so as to reduce the damages to the human being, living organisms, vegetations, earth, etc. And then we saw what are the C's, carbon dioxide, sulfur dioxide, nitrogen are the outcomes of this and particulate matters. Then how they are impacting the surroundings or environment, and at what stages during construction of power plant, during operational stage, and during this third one is on water source, fourth one is mercury, fifth one is air pollution, and sixth one is water pollution. So many pollutions are being seen. One more is there noise pollutions, which are going to cease today. Okay. Then higher health effects of these power plants and air pollution we have seen, and with summarized in one of the tables, standard tables I have obtained, general table, and from that also you can write a short note of that. Health effects of thermal power plant emissions. Okay. So this was about brief about the environmental aspects. First part. Now today we are going to start with the second part of this environment, little bit vast. I will try to explain with speed. Okay. So this environmental impacts. Now we are going to start today with methods to control pollutants. Then this dust handling systems, ESP, scrubbers, water pollution, thermal pollution, noise pollution from thermal power plant, its control. Okay, so before that, just I had some slides or some data obtained during my service in thermal power plant that I just want to put up in front of you as a part of study or as a part of knowledge. So if you consider this 10,000 megawatt power station, then how much energy is required, coal is required, how much oil is required, how much water is required, that is described in this figure. So about 12,000 tons per day coal will be required. Furnace oil requirement will be 101 meter cube per day. See, water requirement 98,000 meter cube, and out of which 50,000, around 50,000 meter cube goes to condenser cooling in a cooling circuit. So then this much is the input. Then emissions are CO2, carbon dioxide is 30,000 tons per day emission from the thermal power plant of a capacity 1000 megawatt. Suppose 250 into 4 megawatts also you can say, or 500 into 2000 megawatt power stations. Then the SOx and NOx components 680 tons per day emission in the atmosphere. The output is 920 megawatt. Out of 920 megawatt is sent to the grid for use, and remaining 80 megawatt through the unit auxiliary transformer UAT is sent back to the system for to run various auxiliaries in the power plant. Means out of 1080 megawatts we use for running the auxiliaries in the power plant, and the total cost of the installment is 5,000 crores rupees. And ash which is coming out is 40. We are burning the coal 12,000 tons per day, and about 30%, you can say 4,200 tons per day is being ash disposed of from the power station. So this much is the pollution resulted from 1,000 megawatt power plant, and this much is the required. So due to this, coal quantity is also reducing, water quantity is also reducing, and furnace oil is also depleting. So this is in short, we have to know about this thermal power. But electricity is an essential thing that is also required. But at the same time, what we are doing with nature or environment impact, you can say, with the due to this thermal power plant is shown with short one figure. Okay, then how much pollution from the coal-based thermal power plant? One more data I obtained in 2000 figure 12 CPCB. Pollutants CO2, particulate matters SO2, and NOx components. So emissions every day, CO2 is 4,24,650 tons per day. Particulate matter 4,000 is its overall from coal in India. So from this much is CO2 emitted. Particulate matter is 4,374 tons per day. SOx components 3,311, and NOx components 4,966 tons per day emission is there. So impact of thermal power plant on environment. So the environment, what we consist of atmosphere at the upper portion, or the air, where the air is there. Biosphere, you can say it as the earth surface, and lithosphere is the below the earth surface or under and area under the earth. Hydrosphere means water area on the earth surface. So how this environment, thermal power plant pollution is impacting on atmosphere, biosphere, and lithosphere. Just we'll see with again some data collected. Impact on atmosphere, power plant offer combustion of coal releases hazardous gases into the air, and we are number of times we have seen C, carbon, carbon dioxide, SOx, NOx components, mercury, etc. are being released along these flue gases, and fly ash, particulate matter also, and that impacts on the atmosphere. Okay. Slide shows will go. It will be better. Okay. So impact on biosphere, just on the surface of the earth, these are the living organisms. The growth of the vegetation is reduced. These birds and all this dies in the early stage, or there is also their growth is reduced. You are seeing the dying of these animals, and very serious impact on the human health. We have discussed in the last class also. Okay. So impact on agriculture, fly ash is spread on the leaves of the plants. Sunlight will be automatically get you can say, which is falling on the trees, gets reduced. The process of photosynthesis also gets reduced. So this enlargement of leaves is reduced, means their growth is reduced, and choking of the stomata. No gas exchange and respiration system, and the release of radon. Radon, one of the most again dangerous release from the combustion of coal, can damage the cells and genetic analysis of the plant. So this radon also is dangerous one. Just a minute.
interruption. Then next slide, we'll see this impact on the atmosphere, or you can say agriculture. Also, this how this acid rain is falling. This the SOx and NOx components flowing in the atmosphere combines with the hydrogen in the atmosphere and forms HNO3 and H2SO4, which are the part which are the form of the acids, and when falling down along with the clouds and rain, so we call them it as acid rains. So due to the acid rains, lake acidification takes place, water quality gets disturbed. This plantation also get vegetation also gets interrupted. Serious impact on this. Then we'll see that we are seeing one by one atmosphere, biosphere, lithosphere is under the earth surface, beneath the surface. How it impact of this thermal power plant. Larger area of land is required for coal-based thermal power plant. Around 559 means 560 hectare area is required for dumping the ash of power plant with a capacity of 500 megawatt. So much area is then again erosion takes place due to the fly ash. Natural soils property changes and becomes more alkaline. So change in land's use pattern, site clearing, impacts is erosion, loss of biodiversity, loss or change of soil quality and quantity, use diversion and acquisition of land in case of power plant with captive mine. Civil works such as earth moving and building structures already we seen, it causes dust pollution as well as noise pollution. Impacts are there. So what thermal pollution? One more point was in our syllabus uh, in the unit. So I have collected the data again from my experience. So data which having with in thermal power plant, I'm just producing it here. Thermal pollution is the harmful increase in the water temperature in streams, rivers, lakes, or occasionally coastal ocean waters. How it is harmful? It is the degradation of water quality by any process that changes ambient water temperature. Because in most of the cases, hot water is being mixed up with the natural water outside. So it changes the ambient temperature and also degradation of water quality. A temperature increase as small as 1 or 2 degrees Celsius can kill native fish inside the sea, ocean, or river, you can say lake, shellfish, and plants, or drive them out in favor of other species, often with undesirable effects. So that is the effect of thermal pollution on the vegetation below the surface of the earth. And what are the causes? The major sources of thermal pollution are discharge of heated water or hot waste material into water bodies from nuclear power plants, industries effluents, domestic sewage, hydroelectric power, coal-fired power plants, and thermal shock. So these are the causes. Means causes we have seen the temperature of ambient water increases, ambient temperature increases, loss of biodiversity, etc., taking place. Other causes are deforestation and soil erosion. These are the main causes of thermal pollution. Then how to control all this? So today we are going to see in brief. I will just fast go through the methods to control pollution caused by thermal power plant. So one of the method is for control of CO2. What we have to do? You have to use cleanest fuel. You have to use high heat content, low ash, and low sulfur coal. Coal washing by means of washing coal coming from the mines and before sending it to the boiler. Use of combined power plants, that is cogeneration. It is a separate chapter. It is a separate syllabus for that. Cogeneration means whatever the exhaust gas is coming out of particularly gas turbine power plant having more of hazardous, you can say, things that may damage to the uh, surroundings or environment. So in order to avoid that, these hot exhaust gases can be reused in another regenerating unit, such as a small thermal power plant, or you can say small that heat can be utilized in the boiler to convert it into steam, and that can be utilized for process industries or for generation of energy, electrical energy. So with the help of combination of the plants, gas turbine and steam turbine, gas plant and steam power plant, you can reduce the content content or CO2. You can control it. Quantity of CO2 can be controlled. Control of sulfur dioxide, there are various approaches. Two main approaches are there. Removal of a sulfur first is a sulfur compound from fuel before burning, that is a desulfurization of fuel. Sulfurization of fuel, desulfurization of fuel, which I have explained is somewhere here at the bottom. Fourth flotation, what is that? I also explained here. Then chemical treatment. By means of chemical treatment, sulfur component can be reduced, and magnetic separation by means of using magnets. The coal which is having high sulfur content can be removed, so that sulfur dioxide control can be quantity can be controlled. Another approach is removal of SO2 from flue gas, that is the flue gas cleaning, wet scrubbing, catalyst oxidation, solid absorbent, and use of low sulfur coals. So these are the methods. Two of these two will be studying. One of these will be wet scrubbers. Will be studying in the following slides. So what is the sources? What is the process of removing sulfur from coal is termed as desulfurization, and can be achieved by various physical, chemical, and biological methods. What is the fourth flotation? Here it is a complex process involving several phases, that is particles, oil droplets, and air bubbles. These bubbles simultaneously interact with each other and with other species, such as the molecules of a promoting region and dissolved ions in water. That is the process of fourth flotation. By this process, we can reduce the quantity of sulfur, percentage of sulfur, while before going to the atmosphere. Then third one is the reduction of temperature in combustion zone. That is a control of NOx component. Reduction in temperature in the combustion zone. Now into 10 megawatt, and we have seen our 250 megawatt, where this pulverized coal is used. The combustion chamber temperature goes around 1400 to 15 degrees centigrade. So which if the temperature is higher and higher, there are chances of more NOx component liberation along with the flue gases. So in order to avoid this liberation of NOx components, you have to maintain the temperature of furnace as low as possible, below 1000 degrees centigrade. And nowadays, I have explained in one of the topics, that is a FBC, fluidized blade combustion chamber boilers can be used, so that if you use fluidized fuel, then this problem of NOx components will be reduced, as the temperature of the furnace goes is around 800 to 900 degrees in case of these FBC boilers. Fourth one is reduction of this wastewater. The water which is going to waste and sent to the atmosphere can be reutilized in the power plant. So how they can be controlled? Wastewater treatment, with the water which is going outside can be collected in the pond, in the sump, you can say. We call it as effluent sump, and in this case some chemicals when added, and this adding the water can be treated, and that wastewater can be used in some of the parts in the parts of the plant, such as firefighting, raw water wherever is required, fly ash removal, bottom ash removal, etc. For that, the water can be reused. So water from hydraulic ash disposal system, that is ash disposal system, can be also reused. Rainwater collection, cooling water used in power plants, that can be also recirculated in the power plant, so that cooling water requirement will be reduced. Filtering and centrifuging. Centrifuging means stirring action. By means of stirring action, the sludge falls down, or the heavy particle falls in the around the walls of the that's centrifuge, and the water particles can be, or water droplets can be taken from the bottom to the reuse. Okay, so these are what is the catalytic oxidation, and then all these things. Highly active absorbent means this I have just given the meaning of them. You can just go through. Okay, so these are the various methods to control. You can have a short note on this, so you can easily write this 1, 2, 3, 4, 5, 6. Mercury control In coal fire boilers, majority of gases having mercury liberated, and in limited fire boilers, majority of gases mercury is HGO. The two technologies used for mercury control are co-benefit technologies like ESP, fabric filter, FGD, SCR, SDA. The not to worry about all this. We will be going to study this ESP. We have already studied. Again, in brief, I will explain about this ESP. And fabric filters are nowadays used to control this mercury quantity before sending into the before it emitting out of the thermal power plants, okay, which are used to remove even particulate matter also is removed, SO2 is also removed, and NOx component is also reduced in addition to mercury. So this mercury control can be done with the help of this ESP, SCR, SDA. I have not so I have worked on the ESP, so I will explain ESP in brief and explain also in thermal power plant chapter. We'll see in the next slide also. So electrostatic precipitator can be explained in number of ways, number of figures are there. So this figure I have just which is shown here, I have explained in this first chapter. So again, in brief, we'll explain here also. The electrostatic precipitator is also called as electrical air cleaner, a device. This is placed in between, you can say, the flue gases after flowing through economizer, air heater, and then comes to electrostatic precipitator, and then finally goes to chimney to the atmosphere with the help of ID fan that I have explained. So what is the electrostatic precipitator is also just read it so that you'll learn. The precipitator functions by applying energy only to the particulate matter being collected. So particulate matter get collected without significantly impeding the flow of gases. Originally designed for recovery of value industrial process materials, electrostatic precipitator are used for air pollution control. So electroprecipitator can capture fine particles up to you can say 2.5 microns in the fly ash, and which are especially dangerous if released because they can be drawn deep into the lungs and can trigger inflammatory reactions. So what is the experience? These hot gases, flue gases coming from the furnace are being going through this electrostatic precipitator. Once again, in brief, I will explain. So this ESP consists of collectors. You are seeing collector plates and electrodes. You can say emitters. So and these collectors and series of electrodes and collector plates are inside this electrostatic. There is a electric field is produced, which explained with the help of this 40 to 80 kilovolt DC transformers are there inside this, so that what happens, an electrostatic field is created inside this, and due to which the fly ash which is flowing along with the exhaust gas gets deionized, and that negative part charge is attracting toward the positive this collector plates, and then this you can say negatively charged flows toward the positive plates, and positively charged ions flows to the emitters, like that. So they are then wrapped with the help of, here somewhere it is written in wrapping of this collecting support per support, and these supports are being wrapped by means of hammers, so that whatever the ash stuck up due to the deionization process. So ionization is shown here. These are the collectors, these are the emitters. So ionization takes place due to the electric field inside this, and that is called as corona effect. You know, it is now the word is famous, corona, but we have already studied this corona effect in this electrostatic pressure. Okay, so negative charge particulates attracted to the positively charged metal plates. So these are the metal rods, electrodes. Okay, so how they solid particulates, then these are the incoming gases, and this outgoing particulate free, means almost all the particulate particles are with 2.5 microns are being attracted in this you can say ESP. Then they are being taken and by means of wrappers, emitter wrappers and collecting wrappers, with the help of hammers they are being hammered, and they fall down in the hoppers, and from the hoppers with the help of water they are dispatched in the form of slurry to the ash sump and ash bund. We have seen that around 559 acres of water area is required to dump this ash for 500 megawatt plant. This is in brief about ESP. Then we'll see wet scrubber. This is the clean in what is the functioning of this wet scrubber. By reading it also we can get the idea. Wet scrubbers can remove particulate matter again by capturing them in liquid droplets. The droplets are then collected with the liquid dissolving or absorbing pollution gases. Any droplet that are in the scrubber inlet gas must be separated from the outlet gas stream using a mist eliminator. So here is a mist eliminator. Okay. Also, the resultant scrapping liquid must be treated prior to any ultimate discharge or being reused in the plant. Means, so these are when the flue gas coming from the you can say before going to the chimney, there it is taken to this or after the chimney or near the chimney, or also you can you can put these scrubbers so that flue gas while flowing in the upward direction, uh, uh, so water is sprayed from the circulation pump so that this gas, the droplets of this ash and water falls down due to the heavy in the bottom side, and the humid air or humid gas which is going to the atmosphere, again many particles are there, they are eliminated in the eliminators, that just like drip eliminators in the cooling tower. So this water which is collected at the bottom, then you can add limestone etc and all this as an reagent, so that uh, water can be treated here, and that water can be used as a gypsum. This becomes gypsum, or and the water also can be reused in this cycle in the power plant. Okay, so this controls particulate matter, even that already showed particulate matter and SO2 components also. So cyclone dust collector one, last one is this one. A cyclone dust collector works by creating a very small controlled hurricane contained inside the housing. This is the cyclone separator. So cyclone is being created by means of hurricane. In the circular winds within the cyclone lift dust and larger particles, much like the winds of hurricane will pick yard debris which see in the nature. The spinning particles are thrown against the wall of the chamber. Heavier metals are falling due to the centrifugal action, are collected at the wall surfaces, and they lose their and but due to centrifugal force, they are going away from the center, and they lose their momentum when they hit the chamber wall and fall down. Due to the heavy particle, they fall down and they are collected in the dust, in the form of dust beneath the cyclone collector. So this cyclone separator can separate more than 99% of dust particles greater than 10 microns. Means you can see again this particulate matter, sulfur contents, whatever it may be, also get reduced. This at a very large in cyclone dust collector. Dust filters in this process can remove dust particles down to a size of 3 microns, and between these two dynamics, the efficiency is increased. So now next one is one more point is left, that is noise pollution control in the power plant. So that again I have some data collected in the thermal power plant. Just I will go through this. Noise pollution control, the entire plant is so installed that resultant noise level within the premises remains with the standard limits. What are the standard limits? Standard for industrial area 70 dB, maximum outside the project property boundary. So means there should be around 70 dB is allowed. If it is more, then you will say that noise pollution. All the equipment in the power plant will be designed to have a good noise level, not exceeding. In power plant, it is about given 85 to 90 dB, whereas outside it should be around 70 or less than 70 dBs as per the requirement of OSHA, Occupational Safety and Health Administration standard. Turbines will be housed in closed buildings, so which will reduce the noise levels. Earlier we have worked in 210 megawatt and also seen 30 to 30 megawatt plants where in the turbines were housed in open space, or they are open. So what was happening? The noise level was much more because of the steam coming, high pressure steam coming, entering into the turbines and giving more and having more noise there due to the rotation of the speed. Also rotation of the turbine also is 3000 rpm, so a lot of noise was there. And in order to control this noise level within the limit of 85 to 90 dB, in nowadays in 250, 500, even I saw 660 megawatt plant of Koradi power plant. I couldn't work there, but it is in our Mahajanko where I worked. I saw there also. I visited and saw these turbines are housed in the, you can say, plastic fiber or uh, fiber material. They so that the noise level is controlled to marginal level. Outside in the turbine house, even I was wondering, I found that absolutely very less sound was noise level was there in 250, 500, and 660 megawatt plants. It means these turbines, due to the housing of the turbines in closed, you can say, fibrous things, or housing, you can say. And now earplugs are also be provided to the workers. We were also using the earplugs wherever the dB was more, and it should be enforced to use by the workers. So that was about the noise pollution and noise pollution control. Conclusion. So now here I'm thought that it will be the last class of this two units, but we have not yet seen this introduction and thermal power plant, that A part, power generation or power general global scenario. So this part is remaining. So here, before concluding that, we have almost covered part B of unit 1 and part A and B of unit 2 in this various around 8 plus 8, 16 to 17 lectures in part 1, energy engineering part 1, and energy engineering part 2. So like that, we have, I think, 2 to 3 in the 3 parts, energy engineering 3 parts. We have divided and tried to complete this all these points with each and every point I have tried to explain with with my experience, with my knowledge, with my industrial practical experience in thermal power plant, and with ease, in easy language, and I have tried my level best. I hope you have understood. So much topics we have discussed in this energy engineering course. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, around 14 lectures. How we compare 14 to 15 lectures through these 15 lectures and 15 video lectures, and also resource files I have attached with each one. So this part I'm also uploading shortly. So by this, I have tried my level best. It is my passion to give to the whatever the knowledge I have acquired in power plants and in industry and in practically. So I uh, hope you have got ample knowledge and also confident, so that you can face the theoretical exam as well as practical exams with confidence, with ease, and with little time required for attention of this. Just by going through these video lectures or research files, i I'm confident you will get definitely more and more score in this subject, and also confident, and you'll never forget whatever taught in this course. So the last part which is remained in this unit 1, part A, that is energy scenario, and these MCQs are also left of unit 1 and 2, MCQs and FAQs on unit 1 and 2 may likely to be asked in the examination in energy engineering. I will take in fourth in the next course because of the time limit of these free video courses, and I will upload them very shortly as part 4 on Udemy, as are almost ready. But before that, I wish, and I want to say here also, I'm getting good response from the students from all over the world. But unfortunately, I'm not getting the valuable feedback and reviews from you people. I again humble request to provide your valuable feedback and reviews, so that if any drawbacks are there or any teaching method can be improvements can be done accordingly if required. Thank you. Thank you very much. And best of luck. We'll meet soon again. Thank you.